Hello, my name is Suritai, and today I will be explaining how to solve the questions in MHF4U Unit 4 Midunit assignment. So let's start. So in the first question, the question said that the regular motion of the Earth about the Sun causes the daily change in the high temperature at any location on Earth. The chart and graph show the average daily high temperature in degrees Celsius for each month in Yellowknife and WT compliant for several years. Determine the trigonometric equation that models this information. Let y be the temperature in degrees Celsius and x be the numerical value of the month. So by looking at the graph, we can know that the x-axis represents the numerical value of the month and y-axis represents the temperature in degrees Celsius. So let's look at the chart. In the chart, the month and the temperature in degrees Celsius are described. By looking at the chart, we can know that the temperature in January is negative 24 degrees Celsius. The temperature in February is negative 21 degrees Celsius. The temperature in March is negative 12 degrees Celsius. The temperature in April is negative 2 degrees Celsius. The temperature in May is 10 degrees Celsius. The temperature in June is 16 degrees Celsius. The temperature in July is 21 degrees Celsius. The temperature in August is 18 degrees Celsius. The temperature in September is 11 degrees Celsius. The temperature in October is 2 degrees Celsius. The temperature in November is negative 10 degrees Celsius. The temperature in December is negative 19 degrees Celsius. So by looking at the chart, we can know that the maximum temperature is 21 degrees Celsius in July, and the minimum temperature is negative 24 degrees Celsius in January. So let's go back to the graph. By looking at the graph, we can know that this is a cosine function graph. As it starts from the maximum, it must have been reflected in the x-axis. So the equation for this graph would be y is equal to negative a cosine k times x plus c. Here, the maximum temperature is negative 21 degrees Celsius. Minimum temperature is negative 24 degrees Celsius. The period is 12 months because there are 12 months from January to December. So to find the amplitude A, the equation is maximum minus minimum over 2. So here we get 21 minus negative 24 over 2. And for the answer, we get negative 22.5. So we get the value of A, it's 22.5. So let's find the value of K. To find the K, we need to know the equation of this period. Period is equal to 2 pi over K. So to determine K, we have to rearrange the equation. K is equal to 2 pi over period. So K is equal to 2 pi over 12, and the value of K becomes pi over 6. In the given graph, there's the horizontal translation, D is 0. So the value of D is 0. To determine the vertical translation C, the equation is C is equal to maximum plus minimum over 2. So here we get 21 plus negative 24 over 2. So the final answer would be C is equal to negative 1.5. So here we get all the value that we need. A is equal to negative 22 A is equal to 22.5, k is equal to pi over 6, d is equal to 0, and c is equal to negative 1.5. So the required trigonometric equation would be y is equal to negative 22.5 cosine pi over 6x minus 1.5. This is the final answer for the question. So let's move on to next question. A Ferris wheel has a diameter of 10 meters and takes 24 seconds to make one revolution. The lowest point on the wheel is 1 meter above the ground. A. Sketch a graph to show how a rider's height above the ground varies with time as the Ferris wheel makes a rotation. Assume the person starts the ride at the lowest point on the wheel. So firstly, we have to sketch the model of Ferris wheel. Here, diameter is 10, so the radius must be 5 meter, and Ferris wheel is 1 meter above the ground. For number A, we have to sketch the graph. So we have to find the points and draw the graph. In the graph, the x-axis represents time in second and the y-axis represents height in meter. B. Write a trigonometric equation that describes the graph. So by looking at the graph, we can know that this is a cosine function, but the graph starts with a minimum point. So the graph must have been reflected in the x-axis. So equation h of t is equal to negative a cosine t times t plus c. Here, the maximum height would be 10 meter plus 1 meter is equal to, so the maximum height becomes 11 meter. And the minimum height would be 1 meter because the Ferris wheel is here, it's 1 meter above the ground. So the lowest point, the minimum point would be 1 meter. And the period would be 24 seconds because here in the question, it said that it takes 24 seconds to make one revolution. So the period would be the time taken to finish one revolution. So period is equal to 24 seconds. So to find the value of A, amplitude is equal to, we have the equation A is equal to maximum minus minimum over 2. So 11 minus 1 over 2. So the final answer for A is 5. And next, we have to find the value of k. Before we find the value of k, we need to know the equation. Period is equal to 2 pi over k. To find the value of k, we have to rearrange the equation. K is equal to 2 pi over period. So we have to substitute the value of period in this equation. And then the final answer for k becomes k is equal to pi over 12. Here in the graph, the horizontal translation d is equal to 0. To find the value of c, vertical translation, the equation would be c is equal to maximum plus minimum over 2. So we have to add 11 plus 1 and then divide it by 2. And the final answer for C is 6. So we get everything we need. A is equal to 5, K is equal to pi over 12, D is equal to 0, C is equal to 6. So the trigonometric function we need is h of t is equal to negative 5 cosine pi over 12 t plus 6. Number C, it is said that check the accuracy of your equation by using t is equal to 12 seconds. Explain why this provides a check of the accuracy of the equation. What are two more values that would provide a good check? So when t is equal to 12, we have to we have to substitute 12 in place of t, and then the final and one t is equal to 12, we get the height is equal to 11 meter. 11 meters. So the equation is accurate because t is equal to 12 at time is equal to 12 is the half time of the wheel's one revolution. So the height at the time must be maximum. The maximum height. So the maximum height of the wheel is the addition of the wheel's diameter and solution. Wheel's diameter, and the distance between the wheel and the ground diameter. So the maximum height is 11 meter. So this indicates time is equal to 12 seconds. The Ferris wheel is at its maximum height, and so 11 meter. And from the equation, we can calculate that at time is equal to 12, then height is 11 meters. So it can indicate that the equation is accurate. So for two other values, I choose t is equal to 6 and t is equal to 24. One t is equal to 6 second, h of t is equal to 6 meter. One t is equal to 6, it's a quarter of one revolution. So the height at the time is the addition of the radius of the Ferris wheel and the distance between the wheel and the ground, 1 meter. So the height at the time must be 6 meter. And from the equation, we can also get 6 meters. So it can prove that our equation is correct. And when t is equal to 24 is the end of one revolution. So at that time, the Ferris wheel must be at its lowest point, minimum height. So at the time, the height must be 1 meter. And from calculation, we can get that h of t at t is equal to 24. We can get 1 meter. So it can also prove that our equation is accurate. So let's move on to next question. In the question, the height of the tide in the Bay of Fundy relative to a pier varies from a low of 4.5 meter at 0208 to a height of 17.3 meter at 0821, measured with a 24-hour clock. Assume that the height h of the tide can be modeled as a cosine function of the time of day t, and then determine the equation in the form h of t is equal to a times cosine k times t minus d plus c, where h of t is the height of the tide at the pier in meters and t is the time of day in hours. So by reading the question, we can know that the maximum height is 70.3 meter at 0821, and the minimum height is 4.5 meter at 0208. So the equation is h of t is equal to a times cosine k times t minus d plus c. To find the value of a, we get the equation. We have the equation a is equal to maximum minus minimum over 2. So we have, from calculation, we know that a is equal to 6.4. For one cycle period, we have to multiply 6 hours 30 minutes with 2 because um, half cycles period is the difference between 0821 and 0208. So the half cycles period, for half cycles period, we get 6 hours 30 minutes. So we have to multiply by 2 to get one cycles period. 6 hours 30 minutes is equal to 6.22 hours. So we get 12.44 hours. So to find the value of k, we have to know the equation. Period is equal to 2 pi over k, and we have to rearrange the equation. K is equal to 2 pi over period. So we get k is equal to 2 pi over 12.44, and we have the value of k becomes 0.505. To find d for the translation, we have 8 hours 8 hour and 21 minutes. So in terms of hours, 8 hour and 21 minutes is equal to 8.35 hour. To find the value of c, vertical translation, we have the equation c is equal to maximum plus minimum over 2. So we have 17.3 plus 4.5 over 2, and the final answer for c is 10.9. So we get everything we need, and we have to substitute them in the equation. So the equation becomes h of t is equal to 6.4 times cosine 0.505 times t minus 8.35 plus 10.9. For C, determine the height of the tire related to the pier at 11:30. Give your answer to the nearest 0.1 meter. So what the time? It's 11:30. It's 11 hour and 30 minutes. So it's equal to 11.5 hour. So we have to substitute 11.5 in place of t, and the final answer becomes 10.8 meter for one decimal place. So the answer for C is 10.8 meter. D, a boat needs a depth of at least 12 meters to dock at the pier. Use a graphical approach to determine when the boat is able to dock and when it must leave. So we have to find the time taken when h of t is equal to 12. So we have to find the time t. Here h of t is equal to 12, and we have to rearrange the equation, and we have to subtract 10.9 from 12 and then divide it by 6.4, and then find the value of 0.505 times t minus 8.5. We have to find the cosine inverse of 1.1 over 6.4, and then finally the value of t becomes 11.12 hour. And I also by looking at the graph, we have points here, and we have the graph being drawn. So by looking at the graph, we can know that when one t is equal to 12, when h of t is equal to 12, the time taken is 5.3 hours, and another time taken is 11.12 hours. So the time taken I mean the time when hydro the time when the depth is 12 meter equal to 11.12 hours. And thank you very much for your attention.